Welcome back to the itchy and scratchy room. To this point on the project, we've wetted out all of our layers, we have our plate ready, we have our tape ready, and we're about to move forward with building the bag. This can be, well, aggravating, but being careful, taking the right steps to make sure that your bagging tape has been put down correctly will save you a lot of trouble. What we want is a good seal all the way around that bag, because air leaks when we pull vacuum will lower our overall vacuum over the part. It's the vacuum that's going to pull everything together. See, the weight of the atmosphere at sea level on a standard day is roughly 14.7 pounds per square inch. Well, if I can remove even 1 atmosphere from under that bag, it lets this outside pressure push down. You can add a lot more pressure to a part using vacuum than you typically could weight, especially in a small area like this. So vacuums, well, heck, it's just magical. So we're going to go ahead and start preparing our part to get our bag in place. Then we can pull our vacuum, we can add our heat, and then we just sit and watch the time for our part to cure. So one of the first things I'm going to do when I'm setting up my bag is I've got to make sure that anything that's going to be in that bag gets included in the process. Well, what's going to be in your bag? Well, we need a way to supply that vacuum, so we're going to use these pucks. As you see, they just come apart. This is what's going to pull the atmosphere out, so it has to be under the bag. I always do this just to be sure. Now on this part, I've got a lot of room around it. Although I know I'm resin rich, I don't have so much that I know that it would pull into a vacuum line. But if it did, you just ruin the line. So I always add a little extra barrier here of bleeder cloth. Bleeder cloth is used in this system to take any excess resin away from the part and catch it into the cloth. So we're going to use it over the part, but I also like to use it under the puck just in case I'm a little too rich. I don't suck goop in my line and have to explain to the boss man that I just wasted some of his money. So we're going to go ahead, we're going to get 1 puck in to monitor the vacuum and 1 to create. The second puck, that's the one that's going to give us a reading so that we know that our vacuum level is correct. So I'm going to go ahead and get them in place. Now I've got to consider what else needs to be involved. Well, I've got to get my heat source in. I also have to get my heat sensing element in so that the bonding machine that's supplying the heat can measure how much heat is there and make those small adjustments to maintain on temperature. So at this point, I know I'm good with my pucks. They're in place. So I'm going to go ahead and start addressing my part. One of the first layers that's going to go down on top of your part is what we refer to as the peel ply. Peel ply is materials that are slick enough that they actually won't bond to your part. If you don't put a peel ply on, it would be the same as building the part on the plate without the release agent. It'll bond permanently to whatever's above it. So I'm going to go ahead and orient my peel ply. It really don't matter which way it turns as long as it's covering your part. And in this case, we're using a Teflon coated, it's a high quality peel ply, so we're assured that it won't bond to this part. A peel ply also serves a second purpose in that the texture of the ply, if you want to paint that part or if you're going to adhere or bond your finished part to something else, it creates a texture. Creates a little tooth on the surface so we could bond to it. If you wanted both sides perfectly clean, then you would need slick pretty shiny, then you would need to put another plate in there of some sort so that you get the smooth finish. On our part that we're building, we desire one smooth side and one side with the peel ply with a little additional tooth, because we're going to prime and paint one side and then we're going to let the other side just show the carbon. Why? Cool. We like it. It looks good. So I'm going to put my peel ply down, and then on top of that I'm going to add another layer. It's perforated so that any excess resin can pass from the part through the peel ply through this. And in this case, my piece is a little bit big, so I'm going to cut it down a little bit in size so that it'll better fit the part. The more accurately we can cut materials and make our bag, the better the process will run for us. So in this case, a little large, I'm going to have it cover. And then my last layer that I put on top of my part is that breather cloth. If it looks like the stuff blankets are made out of on the inside of the fluffy blanket, well, it's because it is. It's a synthetic poly something or another type of material that's, in the sewing world they call it batting. In our world we call it bleeder, because the excess resin will run up into that bleeder, soak in and harden, so when we take our part apart, all of that will peel off, leaving a beautifully clean surface ready to go into the world. So I have my vacuum puck, my vacuum monitor puck, all of my different plies. I have my bagging tape. Now I must get a few more parts under the bag. We're going to use a bonder for this project because it's commonly used in the repair process. In manufacturing processes, they may supply heats by a big oven, they may roll the whole part in, they may supply heat through heat lamps. There's various methods. But when we're repairing small area damage, like we would in aviation, often you'll go with a bonder and a heat blanket and a vacuum source. So in this case, we're going to use our heat blanket. I've got to pass these wires through this tape. Now, a common mistake is putting these wires into our bagging tape too closely together. Well, when you do, you create a little baby tunnel that air from the outside can leak into your bag, lowering your overall vacuum, and that's no good. So we're going to spread those wires out a little bit so that we can put some tape across and really seal around each individual wire, therefore ensuring this sucker ain't sucking no air in it. Now, that will supply our heat, but the system needs feedback. If the bonder supplies heat through changing the voltage of the blanket, and that is the way it works, the bonder needs to know where the heat is at. That's the reason we use these. Referred to pretty commonly as thermocouples, shortened to TC. This senses the amount of heat being produced. It feeds that back to the computer running the bonder. Our programming tells the bonder we want to be at a certain temperature. So it'll supply energy to the blanket heats up, the thermocouple provides a full information loop and feeds back what actually is happening out here. And as the temperature rises and falls, we sense it with the thermocouple, and the computer can adjust how much energy is going to the blanket. That keeps us at a stable temperature. I always put this in, and if it's a large part, we may want to use multiple thermocouples, because when you're measuring temperature over a large area, you don't want to depend on just one, because one area of that part may be receiving a little more or a little less heat than other areas. Your cure wouldn't be as good of a quality. So what we do is, on small parts, 1 or 2 is fine. On large parts, we put several in different areas so that we're getting an average reading. The computer then can make adjustments to make sure the whole surface of the part is being heated properly. So we've got our heat blanket and our TC installed, and we have our wires exiting across our bagging film. Now, to ensure I get a good seal, I'm going to take a piece of tape, and there's varying opinions on how it works. I learned this from an older guy that was pretty darn good at composites, and so I use that method, but there's a lot of very, very brilliant people out there that have different methods. Follow the book first and foremost, and if there's ways to improve upon how you do things, find the way that works for you that gets the good result, because at the end of the day, a quality part's what we're looking for. So I'm going to apply a little tape across these wires, because the plastic bag wouldn't stick to plastic insulation and it would cause a leak. So I'm going to cover across those to create a good seal around each one of those wires. Now here's the point where you can really, really screw this thing up. I ran a test earlier today before I started this project on my heat blanket and on my thermocouples and on my programming. Sometimes you might get in a hurry. You used the blanket yesterday, you used the thermocouple yesterday, everything's going to be great. Then you do all this, try to start your program, and it won't pass the test because maybe a wire broke in that blanket the last time you used it, or that thermocouple got kinked putting it up and damaged it. Now we've done all of this, including the bag, we get ready to run the program, and something's broke. So what do? Always test your blankets, your TCs, before we ever get this far along. That way you won't end up having to tear a bag apart to get a bad blanket, bad TC out of it. So I've got my suction, the puck, I've got my monitor puck, I've got all of my stack up in the right order, my heat blanket and my thermocouple installed. Don't forget the thermocouple, that's a common thing too. So now I'm down to just putting my plastic bag over my part. Now this is a flat part. It doesn't get much better than this. Round or complicated shapes requires you to put pleats in your bags to make sure there's excess material so that it can suck down into all the areas of that part. When you're making a bag to bag a part that's in a mold, you got to gather enough slack so that it can fill in all the gaps. That's when you kind of have to be super pro level on building bags. For this first part, it's pretty straightforward. We may have to make a pleat, I may not, we'll see, but if we do, no problem. I generally start by working, when I'm by myself especially, I start on the side away from me, and I'm simply going to press the bag down into our bagging tape, and I'm going to try to do this in a way that I create no wrinkles. That's the really important part. Now there may be some, even if we do our very best, so be it, we'll fix them. Like right there, I kind of pushed a wrinkle in. Here's the key. If I need to lift this material again and I try to do it slowly, it's going to pull tape, it's going to make a mess. It's kind of like taking a Band-Aid off. A little quick movement and it didn't disturb my tape. Now I can lay my bag back down, no wrinkle. So I'm going to continue to bring this bag around, and when I get to any feature that changes level, I'm going to work really closely to push it in so that I can make sure that it's getting a good seal. Like right here where that tape overlaps, there's a gap. So I'm going to push this plastic down first to make sure I tuck it in the corner, then I'll start moving back out over the rest of the tape. It's the little things that add up. Generally, you won't have one big massive leak. Most of the time, it's a pile of small ones, and then we start chasing those leaks, and it can be time-consuming and aggravating. So I'm going to work my plastic around. So far, pretty good. I've got one little wrinkle there. I'll show you how to deal with those. Not enough that I want remove the entire bag, but as I come around this corner, I can see I'm going to have way too much plastic here for all of it to push down flat. Well, I kind of expected that. I've got a sort of bulky buildup, so the plastic's not going down flat and even. It's having to go over some features. Well, when that happens, you're going to have places where you have too much plastic, and we're going to have to do something to fix that. Right here is where I'm going to create a pleat. A pleat is the same thing as it would be in a pair of pants. It's where we have extra material that forms a feature. So I'm going to take a little bagging tape, and I'm going to look ahead, and it gets easier with practice. And I'm going to create this pleat about the right height I think it needs to be in order to give extra path for that plastic to follow so that it'll seal. Well, I looked at my extra bagging material, and I'm simply going to fold this piece of tape back to create a little mountain that I can add to it, and it's sticky to everything, and this is a pleat. I'm going to ease my bag up just enough that I can put my pleat in. And don't let the legs touch together like I just did, or it is done. So we get to make another one. That's the consternation part. That's the aggravation part. And with practice, you get better. You know, they say wisdom comes from experience, and experience is a product of failure. I've heard somebody say that, smarter than me. And there is so much truth to that. So I'm going to add my little pleat. That gives me an extra length of path to use that extra length of plastic. Then I'm going to bring my bag in, trying to be as wrinkle-free as possible. I'm going to push it in and push it right up across that pleat. And hot dang, I got it right this time. Don't always work the first time. You may have to adjust your pleats as necessary, and sometimes that means a little bit of back and forth. Now, I'm going to examine every inch of this plastic really carefully. If it's not laying flat down, if you can see a wrinkle or you can see where it's doubled up, that will not work. Like I have a bit of a wrinkle here. I'm going to make sure my tape is down into it good, and in some cases where you just got a little too much. It's a little too much plastic. How can I fix it? If it's not too much, or so much that we'd have to make a pleat, often you can go in, pull out, push down and pull out. Take your finger, push that plastic down, and what we're going to create is kind of a reverse pleat. We're going to push that plastic down into that tape, and when it closes back up, it'll seal. So we're going to do a little of that, and well, by golly, I think I'm good to go. Now that we've got a bag, excuse me, over our part and all of our required functions, I've got to set it up so that I can get the vacuum hose and the vacuum monitor hose through that bag for them to function. Well, they're designed to work in a twist lock kind of way. You push in, turn, it locks them in. And if you'll notice, they have this silicone washer, fairly thick, very pliable, so that when it pushes through that plastic, this washer should bond pretty easily to create an airtight seal. Well, you could push and turn, but I have done this, and then I would get a vacuum alarm, a problem. I'd go back, take my puck apart, and realize it never actually went through the plastic. It just stretched it. So what I always do, just to ensure, is I just put a small incision in the middle of that puck so that I know my vacuum fittings are going to pass through that plastic. Then they'll function as advertised, or at least we hope they do. So we're going to push down. You have to line up the pins with the slots. We're going to push down through the plastic and simply turn. As you turn, it's kind of a little ramp system, so as you turn, it's pulling it down tighter. We're going to turn that until we feel that we've got a good tight seal. between our vacuum fitting, the plastic, and the puck beneath it. A lot of times vacuum leaks occur around these pucks, and most of it has to do with not being very careful on how you install them. Now that I have my vacuum system requirements met, I'm simply going to connect the hoses. And remember, I identified earlier this is going to be our vacuum fitting, that's going to be our monitor. It really don't matter, because either way the system will work. But since I started with that thought, I'm going to stay with that thought. So there's my vacuum line. That's what's going to pull the air out from under the plastic. This is my monitor line. Remember, this computer's controlling this. As soon as we get it turned on and program running, it's controlling it. Well, the only way it can control and monitor things is if we give it good information back. And that's what we're about to do. So I've got my bag in place, I have everything connected, and in this case I'm using a bonder and I'm using shop air. Shop air is basically, or plant air, that means the big air compressor in a corner somewhere. Before you ever hook one of those compressors up to one of these machines, make sure you have filtration. We want the air to be dry, no oil, no moisture, or I guess since I'm southern, oil. Maybe if I was northern it'd be oil, but we don't want any of that possibly getting into our machine. It could cause damage, big dollars. So make sure you've got a filtered, clean, dry air pressurization source going to the bonder. It's going to take air pressure and create it to suction, vacuum, because vacuum's what we want. So everything's hooked up. I'm simply going to turn on my knob. And as the vacuum starts to work, it's going to pull all the air out from under that bag. That's kind of cool, isn't it? And as you can see, the bag is pulling around apart. What that's doing is creating quite a bit of pressure that's going to push all those fibers together. That's where the strength of the part comes from. So far, this bag is looking good. Sometimes if they leak, you can hear it, but sometimes leaks are so small, they're ultrasonic. They're above what we're able to hear. Now, they make a tool you can move around your bag, and if it's one of those that's leaking in a range we can't hear, the tool will indicate when you get near it. Man, those are nice. I love them. Now I'm going to check how much vacuum is being created. Your SRM, maintenance manual, engineering data, whatever you may be working from, will indicate how much vacuum needs to be created to make sure that the part has enough pressure to do the job. So we would refer to our book, look at that level of vacuum, and then we're going to check that against what we're creating with the machine. Now, programming a bonder varies. It's a confuser, right? So everybody's got a different way of putting data in, getting data out. On our particular series of bonders, all your data, your temp, your vacuum, your program and all, it's pretty straightforward. They're getting better. The earlier models, they sucked, but it wasn't because of the vacuum they were making, it's the way they function. And working with them was really difficult. These modern bonders are really, really awesome. So input what we want to happen, output what's going on, much easier these days. Right now I'm currently pulling 6 inches of vacuum. What I'd like to see on the project, in accordance, that's IAW, right, with approved data, is I would like to see negative 15 inches. In other words, 15 inches of vacuum. So what I'm going to do now that my bag looks really stable and it doesn't appear I have a lot of leaks, I'm simply going to increase slowly, listening and watching. Woo, 17 inches. I overshot a little bit. So I'm going to back my vacuum down. Slowly, slowly, slowly. Hot diggity dang. 15 inches of vacuum. Now the bag seems very stable, so as long as I have air working here, the machine can hold the vacuum. Now, sometimes, and especially if you want to build something at home, you don't have to have a $37,000 bonder. You can go down and buy a everyday old vacuum pump. I love to go to China Freight, and you can buy one for about $90, a few basic hoses and fittings, and you can create vacuum at home. It's not an unusual thing. A lot of people vacuum seal food. It's the same process. So the vacuum source, where it comes from, is not important. What's important is you get enough vacuum to do the job. So we have the proper vacuum, and I have my program ready. So I'm simply going to tell it to run the program. When it's doing an output test, making sure heat's being generated, it's doing a test to make sure that good data is coming back through the thermocouple, and the machine is happy and it's telling me it's ramping. We're starting that predetermined path to apply heat to this part. So we're doing good, folks. We're doing really, really well. Part seems to be happy. I certainly am. And all we have to do now is wait for the cure cycle to run. We're going to add heat. We've added pressure. Now the other component is time. So the computer's going to start monitoring. It's going to run its full cycle. Then it'll drop temps. Our part will be finished, and we get to open the Christmas present. That's the part I like the most, is seeing that finished product. Seeing those loose fibers and goopy stuff and all this stuff go in, and a smooth, clean, beautiful part come out. There's magic taking place under there right now. I can't wait to see the end result. I bet you feel the same way when you make your first part. And remember, when we do this stuff, if you get to a point to where you're not sure, stop, read, ask questions. You'll get better as you go along. And at this point, we're going to end it here, because we're not going to wait 3 hours in order to see what this result is, but I bet you it's good. Hopefully I'll see you soon on another video, and we'll continue this journey from I would like to know something about composites to I know quite a bit about composites, and now somebody will pay me lots of money. That's what we're here for. That's why we're learning, and I hope to see you soon to help you in that process. All the best from the Itchy and Scratchy Shop. This is Jay, your friendly local A&P instructor. Welcome back to the shop. In our last video, we had taken all the steps and followed our guidance in order to get a composite part ready to go into cure. We left off, we were in cure, we were running our program, and at this point we're going to return today, open our Christmas present. This is always the exciting part, and take a look at our part that we've made. Now I understand that you're kind of anxious, you've been waiting, but there's some things we need to be careful about. When we get ready to take this bag apart, to get our part out of, remember, we've got these little thin thermocouple leads we want to be careful of, and our wires providing power to the heat blanket. So don't just go ripping and tearing. Let's kind of disassemble in an orderly process in order to protect the equipment. Now, the first thing we typically do is shut down the vacuum pump, but I've got a note here. Many times these vacuum pumps build a lot of temperature while they're running, and since they run extended periods of time, they're heat soaked. In order to take care of that pump, because cha-ching, they're high dollar, before you just shut it down, release the vacuum by turning the valve and let that pump circulate some cooler room air without having to be at work, and that'll help cool that pump down. The rule is we typically like for them to run about 5 minutes without a load on them, in order to protect the pump. Well, I've already released the valve, so the pump is cooling off, so I'm going to start disassembling the bag to see what our part looks like. Remember, take good care in disassembly so that we can use this equipment again. I'm going to remove the top sides of our vacuum fittings, and I'm going to take the plastic and I'm going to peel back. And remember, sometimes a little quick snatch will help release the film from the bagging tape. Once my bagging is released, I'm going to lay it aside. Then the next thing I'm going to do is go ahead and pull my pucks out, and we'll set aside our spare bleeder cloth. Keep these pieces together. It's very easy for them to get separated, and then later we're looking for parts to put our vacuum system together. Now right here in this area where our wires pass through that tape is an area we want to be careful with. I generally go beside the wire, and you could use a safety razor, any type of blade, and I simply cut down by that wire so that we don't put so much stress on it, removing it from this bagging tape. This is sticky stuff, it's kind of tough. So I'm going to remove those and remove my heat blanket from the project. And then finally, this is the one that we need to be very careful with. Our thermocouple wire is extremely fragile, such a small wire. Now I'm going to lift away the bleeder ply, and sometimes it gets bonded to the edges, and we can pull it away. And I'm going to reach and pull off these pieces. If we're really resin rich when we assemble this part, even though we've waxed the plate, occasionally it will want to stick to the plate a little bit. But a bit of shock, usually I take a small hammer, will help loosen it. Then we can pull our part off the plate. And as I'm looking at the surface, I can see that it's pulled really smooth. We've got a nice smooth surface, not a lot of air buildup, not a lot of resin buildup. But you see all this flashing around the edges, and that's where that excess resin has been pulled out through that vacuum process. This helps us get to that magical 60-40 ratio we like to see in our parts. At this point, now that I have the part out, I'll start cleaning up my work area, putting away my tools, and getting ready for the next step, which is to clean up all these edges to get a nice finished part. But so far, hopefully you can see, we got a nice smooth finish on one side where we worked against our plate. On the other side, we've got a slight texture where the peel ply transferred that texture onto the part. That'll be awesome later if we need to bond this part to something else, or if we want to prime and paint that part. We'll have that little bit of tooth because the texture of that peel ply. We would clean this part up, we would inspect the part, then we'll go on to the next phase, which is damage insertion, my favorite, and then the repair process. So at this point, we've discussed the basic terms, materials, steps. We've walked through the buildup of a part, the cure of the part, removing it from the bag. So in the next video, we will look at cleaning the part up, inspecting, and then dealing with the repair, which is actually what we do the most of in the aviation side of its repair. I hope you've enjoyed it, and hope you've gotten something from it. As always, the videos are there to fill in a gap, to serve a purpose, to give you a visual. But the video alone doesn't substitute reading your material. In this case, our lab manual, our FAA references. So as you watch along, dig a little deeper. Find out the meaning of terms, investigate, study, and learn. You'll be better for it. Thank you for your time, and I look forward to seeing you again.